today I wanted to talk a bit about computer vision and startups with a pretty heavy emphasis on the startup part, specifically, where, when you find a place to work, what differentiates a startup from, say, academia and industry. And since I hope that some of you are thinking about that, both where should you work after and should you try to do something smaller at a startup, I was hoping I could provide some perspective and happy to answer questions. And in general, also happy to talk to people afterwards, especially if you're thinking about something concrete. You can reach out through Lara, just get my email. Anyway, so let's go. Well, who is this guy? Lara kind of ruined my joke because she introduced me kind of well, but here's my son. He's pretty cute, so I must be doing something right. And as Lara said, I graduated Brown in 2003, finished in 2010 by way of a PhD. My PhD was unrelated to computer vision, not important what it was, but I emphasize that because I really did switch fields. And I hope that in general, people thinking of doing a startup or not feel that there's a lot of flexibility to move around, because there is. I began working with Michael Black, who some of you may have heard of. He's a director at Max Planck Institute who Lara worked with. So he's surely come up. Also, he's pretty well known in computer vision. And I was lucky enough to join him as a postdoc, working with him as a postdoc, despite having almost no experience in computer vision. I did take some of his classes because I was very excited about spinning out technology, web programming, building front-end UXs, and I moved with the whole team and him to MPI, which was super cool. I was lucky enough to be a scientist in his lab working on the tech, but I also had the good fortune of seeing him and the team grow an institute around him, which was a really nice entry to the world of startups. We weren't a startup, we were an academic institution, but starting from zero, literally we were like in a back room somewhere at the beginning, to seeing the institute grow was certainly a very valuable experience. I highly recommend it, startup or not. I started Body Labs in 2013 with Michael, who was still a director at Max Planck, so he had both roles. He wasn't full-time at Body Labs. Alex Weiss, our other technical co-founder, and Bill O'Farrell, who was a seasoned CEO. Bill had other successful computer vision-y type startups in the past. He had something that became Adobe After Effects, another company that was Speechworks, later acquired by Nuance, that did voice recognition. So he was a great fit to help us spin out the technology. We were lucky enough to be acquired by Amazon in 2017, and I've been a corporate dropout since July 2021. Did my time at Amazon. It was a very educational experience, but ultimately I decided I wanted to get back to the world of startups. I'm pretty excited about GPT-3 and working with some former Body Labs folks about connecting the dots between language and computer vision, and certainly language and based ML and products. But I'm not really going to talk about that. Happy to answer questions at the end, but that's not what I'm here to say. What I would like to tell you about is, well, startups. And I will start with Body Labs. So Body Labs was, as I said, started in 2013 and was acquired in 2017. So that's why I have some slides back from 2017. When you have a startup, you have all these different decks for different people. This was sort of a general purpose collection of slides that I uncovered from my Dropbox folder. It'll give you a sense of what was this company doing, what was kind of the pitch, what was the selling point from the perspective of, for example, Amazon, who bought us, or companies we were trying to sell services to. By the end, we had spun Body Labs to be kind of a human-aware AI platform. And our pitch was we had the world's best body model. We had great technology for fitting that body model to data. But the key there is that this was an enabler for making the world more personalized. Making computers understand people allows you to produce products and experiences that are more personalized to the shape of your customers. That is very valuable in worlds like apparel, health and fitness, also potentially gaming. So we explored all of those. By the end, AR was kind of bubbling up as a thing. So we put together this little mini video. Was flashy for 2017, looks a little dated now, but you get the idea. What was kind of the core piece of the puzzle was this generative model of the human body, 3D mesh that was parametric, so it could fit body poses and body shapes to all kinds of data, in this case, 3D scan data. So under the hood, by the end of the time at Body Labs, we were using the simple model developed at MPI by some colleagues of mine. And we were using, of course, deep learning as well as differentiable rendering techniques to fit that model to data. Don't worry if you don't know what those things are. You surely do know what deep learning is, but this is not a lecture about differentiable rendering, so I'm probably not going to talk about it more. The model, though, was trained on a large collection of 3D data, which in some sense was our secret sauce because it would be hard to make your own body model from data you didn't have. And Michael and the team over many years in academia had collected a large corpus of 3D scans, which are still being used, and the corpus is expanding year over year to train all sorts of models, but in this case, simple. So again, a parametric 3D model where there are pose parameters and shape parameters, and so you can capture a full range of human shapes and poses. The kind of real challenge in dealing with 3D scan data, because other companies do collect it, was this problem of mesh registration, which we were working hard on way back, 10 years ago, and Michael was working on it even certainly before that at Brown. That is bringing your 3D data into point-to-point correspondence. You can imagine, of course, as computer vision people, that like if you have raw data and there's no correspondence, it's challenging to build a coherent model of that. But if you can identify on all your 3D scans, points on the shoulder, points on the chest, points on the torso, then you can actually learn some statistics about how those points deform. And basically you're registering a standard template mesh with all of your data. And from there, learning some kind of model. In our case, you're learning the simple model. But the real excitement was when deep learning started to gain traction. This seemed like a really great way to fit image data. You could try to do that before deep learning techniques, and we certainly did, but deep learning, as you know, makes a lot of things work better. In particular, if you want to fit 3D landmarks with the model, that's kind of a standard optimization problem. It's not trivial by any means, but you need to identify the landmarks. And pre-deep learning, it was actually super duper hard to look at an image of someone and get high quality landmarks. It's still far from trivial today to do it really well, but at least it kind of works, which is a huge step forward from when we started working on this a decade ago. And again, once you have the landmarks, you could solve for the model, and certainly you could look for other features as well. So in summary, Body Labs, New York City-based computer vision startup, spin out from Brown and MPI. The takeaway from the deck is, well, we needed to be able to answer why Body Labs and why now. When you're doing a startup, that's kind of the piece of the puzzle. Why are you doing this? Why should this company exist? And why is it a good idea right now, or at least plus or minus a year? Why isn't it already a company? Or is this the right time? So our thesis, looking back, which was pretty much correct, is that as software becomes more intelligent and cameras become more ubiquitous, and certainly they have become a lot more ubiquitous. When we started working with Michael, even smartphones were not exactly a standard way of taking photos. As software becomes more intelligent and cameras become more widespread, and computers need to see and understand the world. And to do this, critically, they need to understand people, because people are where the action is when it comes to understanding photos. Most of the photos you see on the internet or under camera roll only really make sense if you understand people. There may be people in them, or at the very least, there's products and structures that relate to people. So our thesis was, if we have a really high quality 3D model of the human body that's getting better over the time, all the time, then we can use that model to help businesses better understand their customers. And that's where the value comes in. If you understand your customer shape, you can create highly personalized customer experiences and products. So to do that, as I said, we leveraged simple, we leveraged an ever expanding collection of image fitting techniques. And our primary use case was apparel. So obviously it would be nice when you're shopping for clothes or getting clothing made for the company selling you the clothes to know all kinds of great stuff about your shape. And it doesn't need to be super accurate even to improve on current experiences, since typically today you're choosing from a small number of sizes and doing it on a website that knows nothing about what your shape is like. So in fact, there's actually an experience on Amazon's mobile app right now, which our team contributed to, where if you take a picture of yourself, you can get a custom t-shirt, and the t-shirt will be visualized on a 3D model that is shaped like you. Your measurements will be extracted, although not shown to you. And hopefully over time, you'll be able to use this capability to buy other types of clothing as well. But if you're looking for a medium price t-shirt that should fit extremely well, I encourage you to check it out. But it was extremely challenging, not just to build that app, to build workflows that integrated our technology into what companies already did. That's kind of very likely to be a takeaway of any computer vision or machine learning startup that is focused on selling to businesses, because businesses care about what they are making. Oh, whoops, I did not mean to play the audio there. Let me skip that slide because it's not actually that important. I was going to talk about the simple model briefly, but since the audio is playing, I will just skip over that. So apparel companies don't care about technology, they care about selling clothing, and they need end-to-end solutions to do that. And again, stepping up a level, that's going to be true of any business that you sell to. So when you hand them something that even seems pretty polished to you, I mean, you may have been working with this technology for years, you may be really proud of the progress you've made, you're right to be proud, but from their perspective, it seems new, quite raw, it's not integrated into their existing tools. And of course, in practice, things just don't work as well as you think from papers. And so in reality, Body Labs probably could have started later, no regrets, but certainly we felt at the time, boy, this thing is taking forever to spin out. But in reality, the technology just kept getting better and better. And to this day, as you've surely noticed, a lot of the vision of Body Labs has still not been realized. I mentioned an experience on the Amazon app for buying a custom shirt, but you've probably never used that experience, and you surely have not gotten all of your clothing either custom made or recommended based on your perfect fit. It's still a ripe opportunity for different businesses to contribute to, but a big challenge is for that specific use case is integrating with the apparel industry. And we're getting there, but it takes time. The other thing I wanted to emphasize just right up front is that startups really shouldn't do research. We were super lucky to have an amazing team and partnership with Michael's Institute in Tübingen so that we could benefit from ongoing research. And indeed, any startup can benefit from just public research, which is, as we know, being released and made available all the time. I mean, you see all kinds of great new computer vision results coming out each year. And there's all kinds of code that you can play with. But you as even if you're a computer vision centered team at a startup, you really need to be focused on using a technology that works, maybe a new technology, but a technology that works to solve an existing problem, or you take a really tried and true technology solution and apply it to a new domain. But you really want to be at the point where you're saying, okay, this has been demonstrated in papers. It seems like it's working pretty well on my machine. It feels like this is kind of tried and true in the computer vision community at this point. Let's try to sink our teeth into some real world problem and expose it to real users with a heavy emphasis on their end-to-end workflow and their actual customer problem. As I said at the bottom of the slide, my main regret is actually not sinking our teeth into an end-to-end problem sooner. I mentioned the custom t-shirt example that we did at Amazon, which is super, super cool. We actually, towards the end of our time at Amazon, were working with a different apparel company on that, which was great, but I wish we had pushed for that sooner. And certainly we stopped working with them once we were acquired by Amazon, which is fine. But again, I feel like by taking more ownership over the end-to-end, in our case, it might have benefited us because we would have been in more control in steering the technology towards a specific use case that delivered quantifiable customer value. So if you're interested in Body Labs, certainly I can share these slides also, but the video is being recorded. There's some very useful information on MPI's website about the various pieces of tech I mentioned. And there's also a wealth of more recent papers that are certainly worthy of checking out if you are interested in this area. There's a nice Wired piece if you're interested in the founding story of Body Labs, which talks about a neat crime-solving class that Michael Black taught at Brown. Lara was also in the class, but a year after me, but she still got to experience the fun of working in teams to try to use computer vision for a real world application, which was quite challenging. And then I have a little, there's a Wikipedia entry if you're curious about just our funding timeline, just to get a sense of what we were. There's a very old demo you can try called the Body Visualizer. We made that at Max Planck. Prior to forming Body Labs, it lets you construct a 3D body from measurements in real time. It's kind of fun. It's a weird blue color, and perhaps for that reason, it actually went viral on TikTok in 2020, which was hilarious. But basically, it's not actively supported, but it's a fun little toy to play with. So, right, I kind of alluded to this, but am I going to talk more about computer vision? Well, I'd love to. I love computer vision. I could talk all day about the technology involved in Body Labs, but we only have 50 minutes and less than that by a lot now. But I do want to make it clear that computer vision and machine learning is critically important to solving these problems, but it's also the part you already know about. And what you really should be thinking about, in my opinion, is if you love computer vision, even if you don't care about startups, you should think about where you're going to do that computer vision or machine learning or whatever it is you're passionate in the future. So that's kind of the theme for the rest of the talk, starting up specifically, starting up your career or a company if you choose. Where should you do that? What should it look like? So I'll pause for a sec. I don't know if people have any questions. I know I talk fast. All right. Well,
there's no questions yet, but should I, so sometimes it takes a little bit, because then if you ask for questions, then like maybe people will like start thinking, and then like they'll start typing, and then the questions will come in like a few minutes. So maybe you can, in a little while, you can, we can stop again, and then I can, we can answer whatever is there in a couple minutes.
Yeah, well, here's a question too, which I'll, so, well, two questions. So NVIDIA's work, so I think the great thing and the really fun thing about being a startup is you can benefit from all kinds of work. I mean, obviously you can't pivot every time someone releases something new, but I think Michael, starting in the research world, created a culture of sort of nothing is sacred. And I have a slide on this later if I get to it. You fall in love with your problem, not your solution. So you're always looking for the next big thing, or whether the next best tool to solve a problem. That said, it's a balancing act. The pose and shape estimation specifically, it would depend on also the licensing around that, but we were constantly being inspired by what was being released and trying to rethink what we were using. The one piece I would say to that is, in practice in a startup or industry in general, a lot of time data matters more than the specific algorithm. So if you're trying to improve your results, you want to have the best algorithms, but certainly you want to be also collecting the best data. Someone is asking, Body Labs differentiate people. So, we were typically at the time focused on bodies estimation in relatively tight-fitting clothing. Michael has done definitely a bunch of work trying to get at shape under clothing, but we were really working for the use case where the user is kind of cooperative, engaged. It's a fair point, though, that is a significant burden on the user, even if they want you to estimate their shape. So, we would try to leverage a height and weight prior, a strong body prior, and you can have terms that are like one directional. So if you get someone's joints and their silhouette, and you kind of have a one-way objective function where you have to have the body within the silhouette, that can help, but it's hardly the whole story. So there's still a lot to be done in this field, especially if you want to connect the dots to something practical like clothing sizing. So the reason I feel vaguely qualified to talk to you is that I've had the good fortune of working at a successful academic research institution, a startup. At least it was successful enough to get acquired. If it was really successful, I guess I'd still be there, but it was a really good time. And then I also worked at a very successful company, Amazon. Now, all of those places are quite different, and I love, as much as it's helpful to people, to provide my perspective on what joining a startup entails, but that kind of relates to like, well, what are the alternatives? Like, why is a startup? Why is it special? Also, as you can kind of tell, I like to talk about the challenges of turning research into products. A lot of times that boils down to the specifics of the problem being solved too. So again, if you're interested in something specific, either chime in or reach out after the lecture. Because it's hard to really talk in generalities about that. And then, of course, I have, as does anyone who's done a startup, a wealth of advice, but you can kind of take it or leave it, and it becomes more useful when you're actually thinking of starting a company. So academia versus industry versus startups, to me, are kind of the three big buckets of where most computer vision folks or computer science graduates are likely to work. Academic institutions, as you surely noticed, focus on educating students and publishing research, and you're quite familiar with them just by virtue of being there. But individual success, once you're outside of being a student, is typically achieved through publishing and getting tenure. So publishing, getting grants, getting tenure. And that's kind of what success looks like in academia. In industry, and by which I mean well-established, typically publicly traded companies, so big companies, tend to focus on growing existing businesses. They're so big that it's very challenging for one person to move the needle in terms of like the big picture business impact of the company. I mean, if you're hired as like SVP of whatever, yeah, maybe, but at first you're not going to be hired as that. So individual success within a big company like a Google and Amazon is going to typically be achieved through getting promoted and, to be blunt, changing jobs to other big companies or other companies, because that is just in practice a very sensible way to get promoted, in addition to getting promoted internally. And you know, the specific strategizing there depends on the person, the company, the level, but it's true. So startups are a little different. They tend to focus on developing new products, obviously, but they're very focused on finding customers for their new product and finding the funding to get them over the next hurdle. So they're constantly searching for the next path forward, the best path forward. And the interesting thing about startups is that individual success within a startup happens from the startup succeeding and growing. If you're at a startup and it goes out of business, it's not the end of the world, but it's hardly a good outcome for everyone at the startup. If the startup is growing and thriving, then that can, of course, lead to financial rewards, but it'll also lead to all kinds of professional development opportunities. You can take on new tasks. You could head up a team. You could say, oh, I like doing this and not doing this, so let's hire a new person to do this, and I'll go do this really cool thing. Or maybe you'll have the trust of your peers to start up a new initiative and try some ideas that you haven't tried so far. The cool thing, again, about that environment is it is very much the case that, at least until you're quite large as a startup, like hundreds of people, everyone is in that boat together. You know, there are founders that have a lot of equity. There are new employees that have much less equity, but basically everyone believes correctly that if things are going well for the company, they're going well for them. And that's a really cool sense, creates a really cool environment for collaboration that does exist in other places, but the calculus can be different. And certainly if you're looking to coordinate around, you know, a large group of people, you know, several dozen people working on something, academia is a challenge. And industry does do that, but it tends to do that in a very process-heavy way. So should you join a startup? I think so, but I'm a bit biased. And certainly in practice, it depends on both you and the startup. What I think about when my own career or thinking about what advice to give people, I think, well, where are you going to be the best version of yourself? And to get at that, you need to ask about what motivates you. So if you love doing computer vision problems, that's great. That's a motivation. Where will you shine? Where do your abilities and your ability to grow align with what the company wants of you or the academic institution? And then, of course, there's just what's your environment like at the job? And again, this is not something I thought about a lot as a student or even early in my career, but it's something I think a lot about now. What are the individual's incentives, the motivations that motivate people within the organization you're joining? And critically, are those similar to yours? Because if everyone's motivation is, I mean, to get promoted, for example, but you're in it to do amazing computer vision research, there's going to be more tension there. And that's just very natural. It's not because anyone is kind of doing the wrong thing, but again, just thinking about, are your incentives aligned with what is typical in that organization? I see just some quick questions. How do you seek funding? I'll talk a little bit about it later, but if you're really actively doing that, you should reach out to someone like me who's done it before. How much information do you disclose to potential clients? What I was saying just real quick was that you don't need to be as squeamish as you think about sharing information. But in practice, people are going to care much more about the solutions you're providing them and the descriptions of your product, which we will surely love to talk about, and you should, than the underlying technology. It's rare that your raw technology is such a differentiator. You know, you might not want to be giving advice to your literal competition, but it's very uncommon for a company or individual you're talking to as a potential customer to go run and recreate what you're doing, because doing anything is challenging and you're working on it really hard. So for them to say, oh, we'll do what they're doing and spin up that effort is going to be much harder than using what you are already providing them with, assuming it works. So that's my answer to that. One thing I also wanted to emphasize is when you're choosing a place to work, think about what people are doing all day at that place. Just, again, lectures, writing, one-on-one discussions really are the bread and butter of academia. Building and more informal discussions as a team are typical of startups, but there's also, a decent amount of scrambling and saying, what do we need to do to all pitch in and solve the latest problem? At industry, there's more coordination. I do want to say there is also industry environments where there is a lot of just, more of a research lab, and that could be a little bit more in the direction of academia. I believe Facebook or Meta Research has had some of that, and you can ask Lara offline, but that's going to depend on the company. But Amazon doesn't tend to do like research labs, and so they're more integrating the science with the kinds of engineering and product efforts that require typically a lot of coordination. In industry related, you're typically building a component of a solution and a part of a process, and are very focused on kind of building something and planning in a way that plays nice with others, whereas startups are much more focused on owning an end-to-end experience that solves a customer problem, and finding those customers is key. Academics, in contrast, tend to focus on novelty, but the difference between having something demonstrated for a paper and having it actually work in practice is quite a lot. It's hard to appreciate that until you actually go and do it. But do not be discouraged by, oh, someone did this and someone already did this and someone already did this in a paper. So what do I bring to the table? Like, you can bring a ton to the table, even if you literally just implement what other people are publishing. And of course, in practice, when you do that, you're going to see all kinds of ways in which you need to make practical improvements to what they were doing. Whoops, I'm going backwards. So I don't want to dwell too long on this because I don't want to take up all the time, but something I think a lot about is what evaluation looks like for a startup versus in other places. And again, really thinking about who do you need to impress? And let's put a pin on, as a startup, you're looking to impress customers and venture capitalists, or initially angel investors, or even just friends and family who will put in money. But the surefire way to do that is to make sure you are impressing customers and demonstrating value for those customers, and a willingness to eventually give you money in exchange for the product you are producing. Typically in school, you demonstrate that you're succeeding by doing well on tests and exams, which is all well and good, but the real world doesn't quite work like that at all. And even in an industry setting, it's very different than a startup, where in an industry setting, you're going to succeed most readily by, yes, impressing your senior peers, but also just your manager and other higher ups that are, essentially giving you more responsibility and promoting you. But as a startup, it's much more about impressing the customer as a team. So that's the magic of a startup. It is driving the alignment of the team to do work that is aligned with what customers actually want. You cannot think enough about that. How are we doing something that is really going to move the needle for our customers? Who are our customers? Who wants this? And as a result, if you have a startup, if you're running a startup, or you're just at a well-functioning startup, the individual rewards will align with what's good for the company, which will in turn align with what's good for the customer. As Peter Thiel put it, a startup is the largest group of people who you can convince of a plan to build a different future. It is surprisingly hard to convince anyone to do anything at a big company, but certainly changing direction and building something new is particularly hard at big companies, which is why often startups can take on big companies and eventually win. Sorry, just checking the chat because I realized that.
Yeah, there's a few questions there.
Yes. How valuable would you rate having a PhD? That's a great question. In some ways, a PhD is a hedge. It's also an opportunity to build and explore as you're getting the degree, which I don't want to downplay, and that can come down to the specifics of you. I wouldn't say getting a PhD is that important to starting a company. Obviously, even in computer vision, a lot of people don't have a PhD. They have masters, they have good connections to that network. But again, the specific calculus, there's kind of a risk reward calculation there. But feel free to reach out. I would never advise someone who wants to start a company today. They have an idea, they want to go do it, they're hungry, they're excited, to go get a PhD first. But if you're, in a more exploration mode, you want to learn about cool stuff, you're doing well in the program, you feel like there's an opportunity to work with a great advisor, and then you can do some exploration in parallel and incubate ideas, that could absolutely be a win-win situation. Key points about transferring your academic research to a startup. That is a great question. We did that at MPI. There's going to be some kind of headache licensing discussion that is very dependent on the institution involved. But you should try to get some advice from someone who's done it before. And then in parallel, you should just be mindful that work that's already been done has already been done. And it's not as useful as you think it is right now. When you haven't started the company, it seems like all this amazing stuff has already been done. But in practice, that stuff is going to fade away real fast. It's still valuable. And if you need to license it, if there's patents involved, that can be a good thing. And there could be some exchange of equity for the licenses. But don't just feel like you should be giving equity for out of the goodness of your heart for anyone who contributed to the work, simply because it is very easy for a group of academics to sit around and overestimate the amount they've already built. And so, again, it can be there's some politics there, but it's my overwhelming goal is to emphasize, like, the stuff that's already been built is typically not as valuable as it seems, but if there's patents involved, that can be a great thing for a startup as well. And then you can just start those licensing conversations with the institution involved, but you need to have a conversation that's institution specific at that point. Body Labs did that with Brown and MPI. Is there going to be a lot of workload or unstable work? So that is a great question. I think there's a conception that startups can be really hectic. It depends on the startup. Body Labs was a pretty low drama startup, in part because of the founding team. Our CEO had done a lot of the work before, and he was very, very good at being even keeled. It's a red flag if everyone's scrambling all the time. It's not sustainable. Hopefully at a startup, you are motivated to do things that you feel is helping the team and helping you. Just like if you're really into your research, you will work hard at it, after hours, if you certainly be designing during the day. Big companies have their fair share of stress too, depending on the company, just in terms of projects going sideways. So it was not my experience at all that I worked harder at Body Labs than at Amazon. I wouldn't say it was the other way either, but it just was not the case that I was like pulling all-nighters and working on the weekends at Body Labs. But then Amazon was just like, just coasting. And in general, I don't pull all-nighters or work on the weekend, especially since I have kids. So what makes a startup succeed? Typically just seeing the world with fresh eyes and going after the right problem. Bigger companies are typically fixated on growing their existing businesses. So understanding why your point of view is different than theirs is extremely valuable. That will give you a line of sight into the thing that you can do that they are not just maybe not capable of doing, but they are not motivated to do. So for example, like Google makes a lot of money by selling ads. So there's a lot of things that they do that colors their day-to-day work. And Meta was like this as well. And so it can be very challenging at a big company for anyone less than the CEO to really pivot and go on to start up a new effort that cannibalizes an existing business. The best companies do this, but in practice, as a startup, you can deduce whether what you're doing would even be aligned with something an existing larger competitor would even want to do, because you might be going after a small market now that you think will grow, and they're simply not paying attention to that market because it conflicts with their existing sales channels. So key milestones, briefly, someone asked about funding. One thing to think about, so you're going to need to raise money unless for some reason, well, two things. One, you don't need a lot of money, which is great, but obviously very fortunate. Could have a significant other that's also gainfully employed, which would help, and you could be living somewhere that's really low cost. But to grow a team, you definitely need money. The other piece, though, is you might stumble on something that is kind of organically profitable at first. That's great. And in that case, you're still going to want to raise money to grow and scale faster, but the pressure will be a little different. You'll be more in the driver's seat when it comes to fundraising, which is always a great place to be. The first milestone for any startup is finding a founding team that is great, that has a shared vision and complementary skills. If you have that and some big inkling of a plan, you could certainly start talking to your friends and family and potentially raise a pre-seed round. But that depends on who you know and your own family situation. And so, when you're older, your friends tend to have more money than when you're younger. So, but the plus side, sometimes when you're younger, you can get by with less. So anyway, at some point there's a milestone. The real milestone, though, is validating that you not only can build something that sounds cool, but that you have built something which people want. That is key. Someone wants what you build, and it has at least the possibility of making a lot of money. At the seed round stage, founders are pitching a company that is not a guaranteed success, and investors know that. You might be looking for a 3 to 5 chance of a big payoff. Typically, seed round investors are looking for a small chance of a huge payoff, not a high chance of a sort of middling payoff. So again, it's not a sure thing, but you've demonstrated that you have something that people want, and you have demonstrated or convinced the people funding you that this has a chance at being a huge business. As you continue to grow, something to think then the next stages would be showing that a growing number of customers are willing to pay for your product in a repeatable fashion. That's typically associated with the Series A. Then you have demonstrated that you can not only do that, but have a way of acquiring new customers, growing the business. If you have more money to do more marketing or build more features, the business will grow. That is what the Series B is focused on. And if you are lucky enough to get to that point and show that your customer acquisition costs or per customer revenue is going up over time relative to your costs, well, that's to the moon. That's what it takes to really get to an IPO. So, lot to take in, as always. Just feel free to ask some questions. I put some random resources about learning more about startups. Again, reach out to me if you have specific questions. There's a million places to learn about startups, but some good and pretty popular places to start are How to Start a Startup, a class by one of the former head of YC, Sam Altman, Y Combinators. Sorry, when I say YC, I mean Y Combinator, a very well-known startup incubator. They have the Startup Playbook, also put together by Sam Altman, although a number of people contributed and he's the co-founders. There were a bunch of them. Paul Graham, who was one of the co-founders, has some really nice essays about how to start a startup and some other ones that are really useful pearls of wisdom. You can kind of peruse the titles. There's some books and any number of podcasts. For podcasts, I would just look for one that has a company that you're interested in. If you're really at the early stage of starting a company, kind of don't know what it entails, I did like the Startup Podcast. They have some different seasons where they follow different founders. There's one focused on 2 women building a dating app, and you get to hear what it's really like being on the ground and sort of grappling with the uncertainty. The person who made the Startup Podcast, the first season is focused on him, and he also is very candid about what's working and what isn't. And so it's a very good insight into what it's like to actually be a co-founder. We don't have a ton of time left, but real quickly, I wanted to give some tips about execution. My first tip is that execution is messier than you think. There's a lot of iteration. This is my much beloved The Process of Design Squiggle by Damian Newman, and it illustrates quite well what early stages of research in a creative business endeavor or research endeavor looks like. Creativity and invention is difficult to plan, and typically it's messier than people who haven't done it imagine. You typically succeed by iterating quickly, not by having a roadmap for all the steps you will take. You need a compass, a feedback loop, a reliable way to see whether you made progress or whether you need to take a step back, but you don't need a map. If you're good at doing this, my guidance overwhelmingly is this is a superpower that you may not appreciate, because some people are extremely uncomfortable, and it is particularly challenging at big companies sometimes to foster these kinds of processes. But if you're good at facilitating them, that in and of itself is a role for you to play in the world, independent of being a startup. Another piece of advice, real quick, keep it simple. Don't overthink a million new technology features. Just focus on building something people want then focus on demonstrating that it fits a particular market with a particular quantifiable value, and then improve your customer acquisition. Step one is definitely easiest if you and your friends or some people you know well are kind of scratching your own itch. This is something we would use. We absolutely built it and are using it ourselves. Great, someone, at least you, wants what you built. Next question, demonstrate product market fit. This is more challenging. It is hard to find an initial customer base who will actually pay you for something. If you do go the startup route, focus on demonstrating product market fit with as little technology as possible. If you can get by without coding anything and making a fake website to show that people will click on it and say, tell me about this product when it comes out, you are infinitely further ahead than if you start by building something and then it turns out no one is downloading the thing you built. Products versus features, another good distinction relating to what I said. Computer vision is awesome, but it's typically unable of hot new features. It's pretty easy to look at an app and say, boy, this app could do this thing better. That's great. It's cool to demonstrate that. You could probably get a job. But it's much more challenging to get people to switch to a new product. And typically you cannot insert new features into an existing product, although sometimes you can find clever ways to do that. Like a web plugin, for example, might be a way to prototype a feature within a product that you didn't build. In the end though, you really need to think critically, very critically, about how you are providing a basically 10x improvement over something that already exists to certain users so that it is so blindingly obvious once they use it that this is a better solution, they keep using it. It is very challenging to think about how what you will do integrates into someone's life. And what I'm saying relating to that, and quoting Amazon a bit here, work backwards from the customers, work hard to see everything you build from their eyes. It is overwhelmingly challenging to ignore all the technology and architecture decisions and good intentions that went into anything you built. But when there's a glitch, in our case, Body Labs, all the body models had no hair. We knew they had no hair. We definitely had no intention of adding hair. They were bald by design, and it does not seem like being bald would be important. Having someone's hair model would be important for sizing for clothing. But if you show the body model to someone, they will definitely notice immediately that it is a weird color and it is bald. So you just need to be aware of that, and you need to see things from the eyes of your customers, because the customers only see what you have put in front of them on a screen, and there is a whole world of distractions around that screen. So it's challenging, but nothing is sacred except what the customer sees on the screen or in real life, if there's a real world component to your business. So differentiating, there's a question about differentiating, and let's talk about it in the context of this slide, because hey, why not? Well, you know, there's a lot of problems in the world. And so you typically don't want to say, we are going to use this ML to solve a problem. You want to find a problem, fall in love with the problem, and then look for ways to use machine learning to make your solution work. The good news is machine learning and computer vision focus on automating inferences that are typically time consuming and can absolutely make products work faster, better, more efficient. But you need to understand the problem space probably more than you need to understand the technology. There are also many startups, and this is a growing area, I don't discourage you from pursuing it, that are building tools for other people to do machine learning. So in a sense, these are machine learning startups for machine learners and engineers. I don't think that market is saturated in the sense that I am 100% confident 5 years ago, we will be using tools that make today's tools look like garbage. That's not because today's tools are garbage, but that's because that's how all software development works. When you look back, you think, my gosh, how did we ever get by without this? We used to do it this way. It was terrible. But it is challenging, and the best way to probably get in that market is, again, to scratch your own itch. What do you feel there are not great tools to do today when you're doing machine learning or software development? Or in the case of some completely different domain, again, where are existing tools falling short? How do you build a multifaceted skilled team? That is a great question. I had a slide on that, finding a team. I'll talk to that in a second. My other piece of advice relating to everything I just said, try to live in the future in the sense that where are you ahead of the curve? Where do you see where demand is going, technology is headed, what will be around in much greater quantity 5 or 10 years from now? For example, this is not super hip of me, but when over the summer, I started using Replit as a way to code. And I was like, wow, this is amazing. If I use this, I can see this is how everyone is going to code in the future. And certainly GitHub has also released their own cloud-based development environment since Replit started to gain traction. And so you can see that if you're doing that, it's like, wow, okay, I'm kind of living in the future of how software development is going to work. I see what I need, and I'm confident more people are going to need this in the future. Some trends to keep in mind real quick: generative networks, large multimodal transformers, no code or low code solutions, the cloud development tech environments I was just talking about, and AR, VR. These are all areas that are still wide open in terms of potential applications. Real quick, because someone asked specifically about finding a team, the best way to find a team is to network and talk to people. And this is why you should not be squeamish about your ideas. Talk to everyone about everything. Your idea, no fault of your own, is not as good as you think it is. It's not as original as you think it is, but with the right people and the right execution, that idea can probably turn into something that is great. So when you are talking to people, don't underestimate the value of business expertise. Building and selling, oh, I forgot to finish this slide. Building and selling are two sides of the same coin. They are great. They are both critical. If you are a builder, look for someone who's a seller. If you are someone who's good at selling things, look for someone who can build. You need both of those skills more than anything. As a computer vision person, I would also lean on having a solid, technologically competent team. You could certainly have one pure business person and who's a good cultural fit with the team. You jive, you get along well, you collaborate well. That is great, but there's always a great hedge. If you get 2, 3, 4 top computer vision people or engineers in a room, worst case scenario, if you need to do kind of an acqui-hire style exit, you probably could pull that off. I had a slide on selling products versus the company, but we're kind of out of time. Happy to talk to anyone afterwards, but again, I don't know what people's schedules are. So thank you for having me, and I apologize for talking so fast, as always.